Now I want to talk about the different forms of a line. And there's lots of different ways that you can write lines. These just tend to be three of the main forms. And they are point slope, slope intercept, and general form. There's also something called standard form too. So if you've heard of that as well for lines, that's just another form. Your book doesn't really go into it, so I'm not going to go into detail there. We'll focus on these three. But again, if you know another form, such as standard, there are other forms that do exist. These are just three of the more popular ones. So one thing I want you to note is that this here is all the same line. So the forms of the line are completely interchangeable. They're all helpful in their own way, and we can bounce back and forth between them. So here I have an example to start, and then I have the more formal definitions of the three. So in your point slope form, you're going to notice that you're starting with the variable y and x here, of course, and then you're subtracting values from a point, and you're using the slope here as well as part of the formula. So this is your basic setup. This is your basic formula here. And then m is your slope, and x1, y1 is any point on the line. So any point that you have. The slope-intercept form is the y equals mx plus b form, which I think probably most people are familiar with, or at least you're more familiar with that one. M is the slope there, and 0b is specifically the y-intercept. So it's not that you can have any single point you want, like in this first case, b is specifically that y-intercept value. And in the general form, you're going to notice that everything is on the same side, and you have that equals 0 that we've seen before. A, B, and C are real numbers. And also, I didn't add this in, but A and B are not both 0. So obviously, you have some sort of variable there. We're not having everything be 0 in the answer. Now, typically, when you're in general form, we do tend to have integers there. So if we have fractions or decimals, we often will cancel them out by multiplying through by a common denominator or something like that. It's not always necessary, but it tends to be very common. So you will see often that in general form, we do like to clean that up so that it looks pretty nice and everything is typically in integers. Now, let me just show you before we move on how they're interchangeable. So here's an example that starts in the point slope form. I didn't give you the values to start, but you can see that it's in that kind of same form that we have here. But notice that if you start simplifying it, so if I multiply through, I have y minus 6 equals 2x minus 8. And then I can add 6 to both sides. And notice that we started in this point slope form, but we wound up in that, slope-intercept form right there. So we went from one form to the next. You can also put this in the general form by putting everything on the same side. Now, in this case, one thing you can do, so let's start over here. Here, I just brought the y to the other side, bringing it this way, because that way I only had to move one thing. So I have 0 equals 2x minus y minus 2. And then this is actually perfectly fine, but if you don't like having that 0 on the left, you can just rearrange it. 2x minus y minus 2 equals 0. You could also bring everything to the left, and you'll notice that your signs are backwards. A lot of times in general form, we do like to have that leading x be positive. So if you do find that your leading x is negative, you can always multiply everything through by -1 to fix the signs, or just bring it to the other side like I did here. That leaves my x positive. And then I just put my two sides at the end. Again, it's not wrong if your x value is negative. It just tends to be more standard that the x value is positive. It just kind of looks nicer. Now, all three of these forms are good. We're going to use mostly the first two forms, but we will use the third one a little bit. The first form is particularly nice if we're writing an equation and I don't know the y-intercept. So that tends to be very helpful there. We do tend to like to write our final results always in the slope-intercept form. This tends to be the most popular one because it's very helpful. We can find our slope and our y-intercept right away. And the last form tends to be nice, particularly with things like modeling. If you have a more detailed model you're trying to set up for a problem that maybe has multiple equations associated with it, or if I'm using something like a spreadsheet tool like Excel or Google Sheets, then I can kind of keep everything in columns, have my X column, my Y column, my constant column. So again, that tends to be very useful in those situations as well. All right, so we're going to start by practicing how to write equations. So in the past, we've always been given equations and we've been asked to find values on them, right? So plot the points or graph that, solve that equation. So here we're going to work backwards. We're going to have information and we're going to create the equation. So when you write equations of a line, you do need two things. You need a slope and you need a point. Now, if you have the y-intercept, the easiest thing to do is to use that slope-intercept form and simply plug in m and b to find the equation. If you do not have the y-intercept, then it's usually easier to use the point-slope form, plug in the point and the slope, and then you can always simplify that and write it in any form that you need to. As I note here, we typically write our final form in the slope-intercept form. Sometimes we'll write it in the general form, so just make sure you read the directions on how you should write your final answer. Now, I will note there are other ways to write equations. So I know some students may have already learned that to use the slope-intercept form and to solve for b when you don't have the y-intercept. So if you have another technique that you have already know how to find equations, you're more than welcome to use that. So I just wanted to do a little diagram. So if we're writing equations or finding equations, same idea. We need two things. We need the slope and we need a point. Okay. Now, if the point you have is the y-intercept, then I recommending using that y equals mx plus b form. That's your slope-intercept form that I mentioned here. If you have any point, then I recommend you use the y minus y1 equals m times x minus x1 form. So that is your point slope form. And then we can simplify as needed to write our final answer. All right, so let's try some out. Write an equation in point slope form. So this one's kind of directing us which way we should go. For a line with slope 4, oh, that is clearly a wrong word. Let's fix that. That passes through the point -1, 3. Then solve for y. So here we have our slope. So our m is equal to 4, which is good because the first thing we need is our slope. And then the point that we have is -1, 3. So in our point, this is going to be our x1, and this is going to be our y1. I don't have the y-intercept. I'm using this form of the line. So what I do is I just set up my general form. And I'm going to go ahead and plug in for the y1, the m, and the x1. So my y1 here is 3. My m is 4. And my x1 is -1. Just be careful, right? Those formulas do have minus signs. So when you plug in a negative, you just want to be a little bit more careful there. I'm going to clean this up. This becomes a plus here. So this is that point slope form, right? That's the final point slope form, but it does want us to solve for y for our answer. So if you see solve for y, that means they want it in that y equals mx plus b form instead. And all you're going to do is keep simplifying. So I'm going to go ahead, I'm going to distribute that 4 over here. So I have y minus 3 equals 4x plus 4. And then I'm going to go ahead and bring that 3 to the other side. So I'm going to add that 3 to both sides. And what I get is y equals 4x plus 7. Now these are the same exact line. They're just in different forms. So here's that slope-intercept form. Here's that point slope form. Again, we tend to like this form the best because it's much simpler to read, right? It's much cleaner. And I can pick out that slope right away. So notice my slope is still the same. And then now I can pick out my b value, my y-intercept. And this is going to be helpful in a little bit later on when we actually get into graphing and things. Right, let's try another one. Write an equation in point slope form of the line passing through points, this point and this point, and then we're going to solve for y. Again, notice that I don't have a y-intercept here, so I'm going to have to use that point slope form to start. So the question's kind of giving me a little bit of a hint. But whenever I'm writing lines, I do need a slope first. And I don't have a slope here, but I can find it. If I have 2 points, I can find the slope by using y2 minus y1 over x2 minus x1. Right, so let's see, I'm going to do 6 minus -3, and then -2 minus 4. So this is going to give me 6 plus 3 over -2 minus 4, which is, let's see, 9 over -6. And I do want to simplify that. I can divide these both by 3. So I'm going to end up with -3/2. That negative sign can go anywhere I want. So I'm just going to put it out front. And then the second thing I need is a point. And it doesn't matter which point you pick. So pick one of the points. I usually just pick the one that I think is easier to do. So I'm going to just pick this one. These are both kind of equally easy. None of the numbers are very complicated. And then I'm going to go ahead and use that. Again, I don't have a y-intercept here, so I'm going to have to go ahead and plug in to my equation. That looks like this. And we're going to plug in those 3 values. So I have y minus 6, my m is -3/2, and then I have x minus -2. Y minus 6 equals -3/2 x plus 2, just clearing out that negative there. So here's that point slope form, but it does want me to solve for y. So I'm going to go ahead and keep solving here, which is pretty common. It's rare for us to leave this as our final answer just because it's kind of messy looking. So I'm going to keep solving. I'm going to go over here. I'm going to first start by multiplying through. So I have y minus 6 equals -3/2 x plus, now if you can do this in your head, that's fine. But if you can't, just write it out, -3/2 times 2. Now 2 is the same thing as 2 over 1, right? When we multiply our fractions, we're multiplying straight across here. So I end up with -6 over 2, which is -3. Now my last step is I'm going to bring the 6 to the other side. I'm going to go ahead and add it. Now, do notice that I'm not clearing out my fractions here. And the reason I'm not doing that is because I do want to be in the y equals form. So if I end up clearing them out, I'm just going to create more work for myself in the end. So sometimes in this form, you're going to just have to work with fractions. Like I did here, I just work with the fractions. This one was kind of nice because my fraction canceled out. But if it didn't cancel out, then when you add to both sides, you just want to make sure you have common denominators. So you may have a little bit of fraction work that you're going to have to do in some of these problems. Okay, now I'm in the form that we want. We are solved for y. So this is my final result. All right, let's do one more here. Write an equation of the line passing through these 2 points. So again, the first thing I need is a slope. I don't have a slope, so I'm going to have to go ahead and find it. You should always have enough information to find everything that you need. So here, I'm just going to make this my second point. So I'm going to do 0 minus 6, and then -7 minus 0. So let's see, I have -6 over -7. Those 2 negatives will cancel, and I have 6/7. Now I do need a point. I do have 2 points here, so I can choose either one I want. But I am noticing that this point here, that 0, 6, is my y-intercept. And when I have the y-intercept, it's really nice. It makes my life a lot easier. So I'm going to choose the y-intercept. And the reason is because when I have the y-intercept, I know my b value. My b value is 6 here. So if I have the y-intercept, I don't have to go through all this and simplifying, although you can, it still works. This formula works for any single point. So if you forget, just use this one and you'll get the right answer in the end. But if I know I have the y-intercept, I can jump right to this form here. So I can use y equals mx plus b. And then what I do this time is I plug in for the m and I plug in for the b. So I have y equals 6/7 x. And then my b is 6 plus 6, and I am done. You do want to be careful. The x-intercept is not what we want here. It has to be specifically the y-intercept. to use kind of, I call this like the shortcut version. So make sure you have the Y-intercept here. And if you don't, or if you forget, you can always, always, always use this form. This is always going to work. Even with the Y-intercept, you can still plug it in and get the same answer. But if you have the Y-intercept, it's just a little bit faster to write it this way. Now, one reason, sorry, I have to watch my typos here. We like the slope-intercept form of the line so much is that we can quickly pick out the slope and the Y-intercept. So this is really helpful. A lot of times with real-world applications, it is helpful to know the slope because that tells us the rate of change, which we're going to talk about a little bit more. And that Y-intercept sort of tells us our starting value a lot of times in many applications because it's when X is 0. So for most of our applications, we're not usually dealing with negatives. So that X equals 0 value is often our starting point. So it's really helpful if we can just quickly pick out these values. It also helps with graphing too, which we'll see in a little bit. So how can we do that? If you don't have your equation in that form already, and let's say we want to find the slope and the Y-intercept, what you're going to do is you're always going to solve for Y so that you're in that mx plus b form. Now, if you're already in that form, then that's great. You can jump right in. But if you're not, so here we're not in that form, we're in the general form, then we're going to have to solve for Y. So the first thing we're typically going to do is bring the X to the other side. So I have 2y minus 4 equals negative 3x. And then I'm also going to bring the 4 to the other side. I'm going to add 4 to both sides. So I'm just trying to get everything away from the y. So that looks much better. I'm not quite done though. I do need to get rid of the 2. So when I divide, you are dividing both sides by 2, but really that means you're dividing each piece by 2. So you do want to split this on the right side and just clean it up. So I'm going to end up with y equals negative 3/2 x plus 2. 4 divided by 2 is 2. And then now you can just kind of match this up, right? So notice my m value is with the x. And then that b value is your other number. So here my slope is m equals negative 3/2. And my y-intercept is 0, 2, right? Because it's 0, b. Okay. Now notice that I can't find these right away if I'm not in the y equals mx plus b form. So you do need to make sure you solve first. Your slope is not 3. It's not always just whatever's with the x. You have to be in the right form first, and then you can pick out that slope in y-intercept.